Welcome back to the Professor Insight podcast, the space where we explore the intersection of artificial intelligence, neuroscience, and emerging technology, and turn it into something practical for your business, your strategy, and your everyday thinking. I'm your host, Professor Billy. As always, a quick note before we begin. This podcast is fully powered by AI tools, from content creation to script writing and voice generation. And yes, what you're hearing right now is a voice clone of me, brought to life with full human oversight and manual curation. I'm thrilled you're tuning in for today's episode because we're about to unpack one of the most important and intriguing questions in modern science and technology, and frankly, a question that has driven my own career for the past decade. Can we actually predict what a human will decide before they do? Today's episode is built around a major new paper published in Nature Human Behaviour. That's right, one of the world's top scientific journals. The article is titled Predicting Human Decisions with Behavioral Theories and Machine Learning. Here's the big idea. For decades, scientists have tried to model how we make choices, especially in those tricky situations where risk, uncertainty, and even a little bit of temptation come into play. Think lottery tickets, financial gambles, even everyday trade-offs. We have all these famous models: expected utility, prospect theory, fancy neural nets from the machine learning world. But none of them, not one, has been able to consistently predict what people will actually do, even on the most basic tasks. Sometimes it's as if the human mind is just too noisy, too quirky, too, human. But what if we've been going about this the wrong way? What if, instead of just throwing more data or more algorithms at the problem, we actually try to combine the best of both worlds, the rich insights of behavioral theory and the raw predictive power of machine learning? That's exactly what the authors of this paper set out to do, and the results are nothing short of astonishing. At the center of the story is BeastGB, a new hybrid model that blends deep psychological insights with cutting-edge machine learning techniques. BeastGB isn't just another machine learning model. It's infused with human elements at its core. It draws on decades of behavioral research, encoding how people actually perceive risk, make trade-offs, and even fall into predictable cognitive biases. These psychological signatures are built right into the features and logic of the model, allowing BeastGB to see the world not just through numbers, but through the lens of real human thought. That's what gives it an edge over models that rely on data alone. One of the most revealing findings from this paper is how BeastGB outperforms purely AI-driven or data-only models, even those based on powerful deep learning and neural networks. The researchers ran head-to-head comparisons across multiple datasets and found that machine learning models relying solely on raw data simply couldn't match the predictive accuracy of BeastGB, especially when the amount of available data was limited or when the task became more psychologically complex. What makes BeastGB stand out isn't just its technical sophistication, but the fact that it embeds genuine human insight into the algorithm. It leverages patterns in how real people think, evaluate risk, and make trade-offs, elements that pure AI, trained only on numbers, tends to overlook. This hybrid approach shows us that even as machine learning becomes ever more advanced, we still need the human element, the intuition, the psychological nuance, and the behavioral principles that turn data into true understanding. And here is a plug for my recent startup. The findings of the paper is exactly why we developed Accurment, to be a true thought partner for marketers, not just another automation tool. Much like the research we're discussing today, which shows the power of blending behavioral theory with machine learning, Accurement brings together scientific evidence and human creativity. We believe that the smartest decisions happen when AI empowers people, not replaces them. In fact, most marketing is still driven by gut instinct, while traditional consultancy is too slow or expensive for most organizations. Accurement changes that. It's a strategic decision engine powered by expert-curated behavioral science and real industry know-how. Our platform gives you instant, actionable, research-backed advice at every stage of your marketing journey. If you'd like to learn more, just head to www.accurment.com. Now, let's dive into the article titled Predicting Human Decisions with Behavioral Theories and Machine Learning.
Okay, Let's unpack this. Today, we're diving into one of the most persistent and frankly fascinating challenges out there. It's something that's stumped scientists, businesses, well, everyone, for centuries, predicting how we humans will actually decide when faced with risk and uncertainty.
hmm It's everywhere, isn't it?
It really is. I mean, think about it. Choosing a health plan, making a financial investment, setting environmental
Or
policies.
even just managing a project at work.
Exactly. These decisions are fundamental, and for generations, truly getting it right has felt like, well, like trying to hit a moving target in the dark.
Yeah, notoriously tricky.
And what's really counterintuitive, I think, is that for a long time, even advanced artificial intelligence, the tech hero that's revolutionized so many fields.
Like medicine, self-driving cars.
Right. Even AI seemed to hit a wall here. It turns out simply feeding AI more data or giving it more powerful algorithms just wasn't quite enough.
No, the raw power wasn't the whole answer.
The real breakthrough, it seems, didn't come from pure computational muscle, but from a surprising combination, almost an unlikely partnership.
A hybrid approach.
Precisely. And that's what we're exploring today, a really cutting-edge working paper called Predicting Human Decisions with Behavioral Theories and Machine Learning. It centers on this remarkable new model called Beast GB.
It's the one. Beast gradient boosting.
So our mission today, for you listening, is to show why integrating these deep, kind of nuanced insights about human behavior with the raw predictive power of AI isn't just some clever trick.
Mm-hmm. Or just an academic exercise.
Exactly. It's a fundamental shift.
Yeah.
You'll discover how this hybrid approach makes AI more accurate, incredibly efficient, and maybe most interestingly, helps us understand ourselves a bit better, too.
It's a feedback loop in a way.
Yeah. And we'll give you specific, actionable takeaways, things you can apply whether you're, deeply involved in building AI systems or maybe just aiming to use them more effectively day to day or in your business.
All good.
So historically, predicting human choices under uncertainty, I mean, even in situations that seem simple, like picking between hypothetical lotteries.
Yeah, the classic experiment.
It's been notoriously difficult. We've had centuries of brilliant minds working on this, creating dozens of sophisticated models.
Prospect theory, expected utility, all sorts.
Right. But no single approach has ever really nailed it with consistently accurate predictions. It's just a real testament to how intricate, maybe even messy, human thinking can be.
It is complex.
And here's where this story gets even more surprising, I think. When modern machine learning tools, the ones that conquered so many other complex data problems, first entered this arena, they actually stumbled.
That was a bit of a shock for some people.
Definitely. In one notable early event, a choice prediction competition, these purely data-driven machine learning models, the ones everyone kind of expected to just dominate,
The black boxes, yeah.
they actually performed poorly compared to models that had this secret sauce of incorporating behavioral insights.
Right. It really defied the initial expectations. The assumption was, give ML enough data, and it'll figure anything out, probably setting the upper limit for accuracy.
But not here, not initially anyway.
No. In this specific challenge, it turned out that behavioral theory unexpectedly pointed the way forward.
So that's where the groundwork was laid for what we're calling this hybrid approach.
Exactly. The paper introduces Beast GB, which, as I said, stands for Beast Gradient Boosting.
Yeah.
Now, at its core is Beast. That's a behavioral model. But it was designed with a really critical difference from many older theories.
Okay.
It was built specifically for prediction, not just for explaining why humans deviate from, say, perfect economic rationality.
Mm-hmm.
It's about forecasting the choice itself.
So outcome focused.
Precisely. Beast suggests that our choices come from, and this is their term, a potentially biased mental sampling process.
Mental sampling, like running simulations in your head.
Kind of. Imagine your mind quickly sampling, or running through possible outcomes, often with some built-in biases, and then combining that with your sensitivity to expected values.
Expected value being the sort of long-run average payout.
Exactly, the average outcome if you play that lottery many, many times. So, Beast GB takes Beast's quantitative predictions.
It's best guess.
It's best guess, yeah. And it combines features engineered directly from Beast's core behavioral assumptions, like how we perceive risk or value, with a really powerful machine learning algorithm called extreme gradient boosting, XGB.
Okay, XGB. Now, for those of us who aren't AI architects, can you give us a quick, sort of accessible way to think about XGB? What makes it so powerful?
Absolutely. Think of XGB like assembling a super team of many specialized but maybe simpler AI models, like decision trees.
Okay, a team.
Yeah, a team. And each new model it adds learns specifically from the mistakes the previous ones made. It keeps refining, correcting the errors, getting better and better.
Iterative improvement.
Exactly. This iterative process makes the overall final prediction incredibly precise. So when we talk about BeastGB, it's like giving this brilliant student our XGD algorithm, a highly intuitive, experience-based cheat sheet.
The cheat sheet being Beast's behavioral insight.
That's it. It's far more effective, it turns out, than just handing the student a mountain of raw numbers and saying, okay, figure out human nature from scratch.
That makes sense. And this hybrid model, BeastGB, it really proved its worth in this big competition, right? CPC 18.
It absolutely did. The Choice Prediction Competition 2018. It was a major test, specifically designed for understanding human choice under risk. And BeastGB didn't just compete.
It won.
It won. Dominated, really.
Yeah.
It captured an impressive 92.6% completeness.
Okay, 92.6% completeness. For our listeners, can you break that down? What does completeness mean in, like, practical terms?
Good question.
Yeah.
Think of predicting human choice like trying to solve a very complex jigsaw puzzle with lots of subtle pieces. 92.6% completeness means BeastGB managed to place almost every single predictable piece correctly. It accounted for nearly all the patterns in how people chose, leaving only tiny, truly random bits, the unpredictable noise unexplained.
Wow. So it solved almost the entire solvable part of the puzzle.
Pretty much. It's a really significant achievement in this field.
And what's driving that? What's under the hood? You mentioned features.
All right. What's particularly fascinating is looking at the types of features BeastGB uses. It doesn't just rely on the objective details, like the exact lottery payouts or probabilities.
Or raw facts.
The raw facts, yes.
Yeah.
It also incorporates what the paper calls naive, features things like the simple difference in expected values. Basic intuitions many people might have.
Okay.
But crucially, it leverages psychological insight features. These are like deeper, handcrafted principles about human nature, derived directly from Beast's core behavioral mechanisms, how we perceive gains versus losses, for instance.
Got it. Insights based on the theory.
Exactly. And then there's the really powerful behavioral foresight feature. This is simply Beast's own direct prediction for any given choice task.
So Beast makes a prediction, and that prediction itself becomes an input for the bigger XGB model.
Precisely. It's a key piece of information.
So it really highlights that it's not just the raw data, but also how we frame that data through the lens of human behavior that makes the difference. That feels quite counterintuitive for people who assume pure data processing is always king.
It really does. And the analysis of feature importance, basically asking the model what inputs mattered most, drives this home. The researchers found that removing Beast's direct prediction, that behavioral foresight feature, caused the biggest single drop in BeastGB's accuracy.
Really? Taking out Beast's guess hurt the most?
By far. It essentially doubled the prediction error, dropping the completeness score significantly down to about 82.8%.
Wow.
This tells us that Beast, even on its own, provides incredibly accurate initial predictions for these kinds of choices. It's already got a good handle on things.
That's impressive in itself.
It is. And here's another really surprising fact, I think. They tested other classical behavioral models, famous ones, like different versions of prospect theory.
Okay, the established theories.
Right. They plugged those theories' predictions in as the foresight feature instead of Beast's. And Beast's predictions were uniquely powerful.
How much difference did it make?
A huge difference. Using Beast as foresight allowed the hybrid model to reach that 90% completeness mark, capturing almost all the predictable patterns just with that feature plus XGB.
Okay.
The next best, which was a version of cumulative prospect theory, only allowed the hybrid model to reach 67% completeness when used as the foresight feature.
67 versus 90, that's a massive gap.
It's enormous. It shows that Beast's specific way of modeling human intuition for prediction was just far more effective in this context than other well-known theories.
Wow. So even with all the raw data and the power of XGB, the specific kind of human intuition built into Beast still dramatically outperformed other ways of thinking about it, and definitely outperformed purely data-driven attempts. That's genuinely astounding.
It really points to the value of having a prediction-focused behavioral theory.
So let's bring this back to listener. What does this mean for you if you're interacting with AI, maybe designing AI systems, or just using them in your business?
Well, it's a really clear signal, isn't it, that human-like intuition, even a simplified prediction-focused model of it like Beast's, can be a critical input for better AI performance.
Don't just throw data at the wall.
Exactly.
Yeah.
It suggests that simply feeding AI raw data isn't always the best strategy, especially for complex human behaviors. Providing what the paper calls domain-relevant knowledge, insights about the specific area in a structured, pre-processed way, can be a massive accelerator.
It helps the AI learn faster and smarter.
Yes. And for businesses, this is potentially huge. It means identifying and maybe even trying to encode your existing expert knowledge about customer behavior, user choices, whatever it might be. That isn't just a nice to have.
It could be vital.
It could be a vital step for truly effective AI deployment. Imagine fine-tuning your marketing campaigns not just on demographics, but on predicted psychological responses with surgical precision.
Or designing public health initiatives that actually resonate with how people make decisions,
Yeah.
instead of fighting against ingrained biases.
Exactly. That's the kind of power this hybrid AI approach unlocks. It allows for more nuanced and effective strategies.
Okay, but this raises another interesting question, maybe a common assumption about the abundance of data. We often hear, oh, with enough data, AI can figure out anything, even without explicit rules or theories.
The big data solves all problems idea, yeah.
Right. So does behavioral theory like BEAST still matter when you have a truly massive data set, like mountains of information?
That's a great question, and the researchers tested exactly that. They turned to a data set called Choices 13K.
13,000 choices.
Almost. It's the largest publicly available data set of human choice under risk and uncertainty, with nearly 10,000 distinct choice tasks or problems.
Wow. Okay. That's a lot.
It is. And importantly, prior studies using this data set had shown that purely data-driven approaches like deep neural networks could actually achieve very high accuracy here.
So the data-only methods worked well on this big data set.
They did, which makes what BeastGB did even more remarkable.
Okay, what happened?
Well, first, BeastGB achieved state-of-the-art accuracy on Choices 13K as well, hitting 96.2% completeness. So it solved nearly 96% of the human choice puzzle in this massive data set.
It's still incredibly high performance.
Absolutely top tier. But here's the truly surprising fact, and this is where it gets really interesting for businesses.
Yeah.
BeastGB needed dramatically fewer training examples to reach this high accuracy.
How much fewer?
Get this. When trained on just 2% of the data, that's about 176 choice tasks out of nearly 10,000.
Tiny fraction.
Tiny fraction. It already outperformed a top deep neural network model that was trained on all 9,000 plus tasks.
Wait, seriously, 2% of the data beat a complex neural net trained on 100%.
That's what the results show. It's a staggering difference in efficiency.
That has huge implications.
It does. The implication for businesses, especially, is massive for something called sample efficiency. It basically means you might not need an absolutely insurmountable amount of historical data to get accurate predictions.
Which can be a major barrier.
A huge barrier. Data collection is expensive, time-consuming. If you can effectively integrate behavioral theory into your AI, you can potentially achieve strong predictive performance with substantially less data.
That saves significant time, resources.
Exactly. Think about piloting new products, testing new website designs, trying out new policies, or even entering new markets where you don't have much history. This approach means you could get strong insights and accurate predictions much, much faster.
Less data needed to get going.
Right. And interestingly, even with this abundance of data in Choices 13K, well, the direct prediction of Beast itself, the foresight feature became a bit less critical than in the smaller data set.
Okay.
The psychological insight features those underlying behavioral mechanisms derived from Beast remain vital. They were still super important for achieving that top accuracy.
So even when the AI could potentially learn patterns from tons of data, giving it those structured behavioral rules still provided a superior advantage.
It seems so. It suggests these explicit behavioral mechanisms offer a kind of structural advantage, helping the AI learn more intelligently, not just memorize patterns.
That's powerful. Okay, so it's efficient, it works with less data. But here's where the plot, for me, truly thickens. This challenges everything I thought I knew about relying on theories. What happens when the underlying behavioral theory itself isn't perfect? Or maybe it even performs quite poorly in certain situations. Does the whole hybrid approach just fall apart then?
That's the acid test, isn't it?
It feels like it. And the researchers put BeastGB right to that test. They used a data set called EP22.
Right. AB22 is different. It included tasks specifically designed to produce strong context effects, situations where people often didn't choose the option with the higher expected value.
So choices that directly challenged Beast's core assumptions about expected value sensitivity.
Exactly. These were tasks designed to make a model like Beast stumble.
And did it? Did the original Beast model struggle here?
It did. The initial result was pretty striking. The original untrained Beast model performed very poorly on this data set. It only achieved about 36% completeness.
36%. Okay, so Beast itself wasn't good at predicted choices in this tricky context.
Not at all. By itself, it failed pretty badly here.
So now the crucial question. What happened to BeastGB, the hybrid model that used this failing Beast prediction as an input?
This is the counterintuitive magic. Despite Beast's poor standalone performance, BeastGB, which remember used Beast's inaccurate predictions as a key feature, still outperformed all other models tested on EP22.
Get out, even using the bad prediction.
Even using the bad prediction. It achieved an impressive 94.8% completeness.
95% accuracy, basically, while relying on a component that was only getting 36% right on its own. How is that possible?
And here's maybe the most surprising fact of all from this part. Even though Beast's prediction was way off on average, that foresight feature, Beast's initial bad prediction, remained the single most important feature for BeastGB's success, according to the feature importance analyses.
The most important feature was the one that was wrong.
On average, yes, but wrong doesn't mean useless here.
Okay, you have to explain this. How can the AI leverage a flawed prediction and still come out on top?
So what this suggests is profound. Even an imperfect, or let's say failing behavioral model can still hold valuable information. Maybe not its absolute accuracy, but perhaps in its rank order information.
Meaning, like, it might still know which option is better, even if it's wrong about how much better.
Exactly. Or it provides some kind of structural insight, some underlying pattern that the machine learning component can then grab onto, learn from, and crucially, correct for.
Ah, so the XGB part identifies the errors in the Beast prediction and fixes them.
Precisely. The ML component essentially identifies and fixes the context-dependent miscalibrations of the theory. It learns when and how Beast is likely to be wrong in this specific context and adjusts accordingly.
Wow. That's incredibly robust.
It is. And the implication for businesses here is really clear, and maybe a relief. Don't necessarily discard a model, a heuristic, or behavioral theory simply because it struggles in certain contexts or isn't perfectly accurate everywhere.
Don't throw the baby out with bathwater.
Exactly.
Yeah.
AI, particularly these hybrid models, can still potentially extract latent value from it. The AI can identify how and why the theory fails in specific situations and then compensate, leading to incredibly robust overall performance even when no single part of the system is perfect on its own.
It's like having a brilliant editor, as you said, who can take a flawed manuscript but see the underlying good structure and turn it into a bestseller, knowing exactly what to fix and enhance.
That's a great analogy. The ML part acts like that sophisticated editor for the behavioral theory's raw draft.
Okay, so this is fascinating. We've seen it's more accurate, more efficient, surprisingly robust, even with flawed components. But what does this all mean for us beyond just getting better predictions? It sounds like there's something deeper here about, well, understanding.
Exactly. It's not just a better black box. BeastGB actually acts as a powerful theoretical diagnostic tool.
How so?
By systematically analyzing where BeastGB's predictions, the really accurate ones, differed from the original Beast predictions, researchers could pinpoint specific choice patterns that Beast overlooked.
Using the hybrid success to find the theory's blind spots.
Precisely. For example, they found Beast predictions were sometimes just too extreme, maybe influenced by noise and online experimental data. That needed tempering. They also identified a gain-seeking tendency in certain contexts. This actually contradicted the traditional idea of loss aversion, the famous concept that people feel the pain of a loss more strongly than the pleasure of an equivalent gain. Here, sometimes people were more focused on potential gains.
Interesting. So it challenged established ideas, too.
It did. And it also showed that Beast assumed its internal mechanisms worked the same way all the time, when actually the data suggested people dynamically adjust their approach depending on the context.
So the model needed to be more flexible.
Right. And the direct impact of uncovering these specific shortcomings was truly insightful. These discoveries led directly to a simple correction, not a complex overhaul, but targeted adjustments to the original Beast model itself.
They improved the core theory based on what the hybrid model revealed.
Yes. And this corrected version of Beast then showed improved predictive performance across all the data sets they tested, without increasing its complexity or making it harder to understand.
That is a powerful feedback loop. So for businesses listening, this means hybrid AI isn't just a prediction engine you plug in and forget.
Not at all. It can be a dynamic tool, a powerful feedback loop to help you refine your own business models, your marketing strategies, or even your fundamental assumptions about customer behavior.
It helps you identify precisely where your current mental models or internal theories might be falling short.
And suggests concrete, data-driven ways to improve them. It's using AI not just for answers, but to sharpen the questions you ask about your own operations and customers.
That's a real game changer, using AI to improve human understanding, not just replace it.
It absolutely is. And there's one more crucial aspect: context generalization.
Right, the ability to work in new situations. That's the holy grail for models, isn't it?
It really is one of the most desirable properties. You don't want a model that only works on the exact data it was trained on. You need it to generalize.
So how did BeastGB do there?
It excelled. It was trained on data from certain experimental contexts, certain types of lottery designs, let's say. Then it was tested on its ability to predict behavior in entirely different, unseen experimental contexts.
New territory.
Completely new territory for the model. And it successfully predicted behavior there, achieving 87.2% completeness. Still very high accuracy in an unseen environment.
That's strong generalization.
Very strong. And here's a final surprising fact, perhaps. It even outperformed what they called direct empirical generalizations.
What does that mean?
It means BeastGB was more accurate than simply assuming people would behave exactly the same way in a new context as they did in a known similar context. Even when the tasks were identical, but the context changed slightly.
So just copying past behavior wasn't as good as the model's prediction.
Right. BeastGB improved accuracy by about 13% over that simple baseline for identical tasks presented in different experimental settings.
Why would that be?
It implies that the hybrid model isn't just fitting the quirks of one specific data set or context. It's actually capturing more fundamental, generalizable choice tendencies, the underlying behavioral patterns that persist across different situations.
That makes it much more reliable in the real world.
Absolutely. For any business, this means models built with this kind of hybrid approach are likely to be far more robust and adaptable. They're more likely to work effectively when you deploy them in new markets or with new customer segments, or when business conditions inevitably evolve.
Like launching a product globally or adapting to sudden shifts in consumer sentiment, these models are potentially built for that kind of real-world resilience.
That's the promise. They capture something deeper than surface-level correlations, giving you a significant strategic advantage in a changing world.
Wow. Okay, so this deep dive into BeastGB has really, I think, shown us the profound synergy happening here between behavioral theory and machine learning. It's definitely not about choosing one versus the other.
No, not at all. It's about a powerful and, as we've seen, often surprising integration that genuinely elevates both fields.
So let's quickly recap the practical takeaways for listeners.
Sure. I think for anyone using AI or even just affected by it, the message is, don't underestimate the power of structured, theory-informed features. Giving your AI insights, like these psychological insights or behavioral foresight, can significantly boost its predictive power, its efficiency, make it work with less data.
Feed the AI insights, not just raw numbers.
In essence, yes. And for businesses, this translates directly into potentially faster development cycles, less need for massive, costly data collection up front.
Which lowers the barrier to entry for using sophisticated AI.
It does. Plus, you get more robust predictions that actually generalize across diverse contexts. And maybe most transformatively, you gain the ability to use AI not just for answers, but as a tool for refining your fundamental understanding of human behavior itself.
Allowing you to iterate, learn, and improve your own strategies with unprecedented precision.
Exactly. It's a continuous improvement engine.
This really raises, I think, an important final question for all of us as AI continues its rapid evolution. If combining behavioral science with ML is this powerful, how might integrating even deeper insights from other human-focused fields, maybe sociology, anthropology, perhaps even biology or neuroscience, unlock entirely new levels of predictive power and understanding for us?
What other human insights are currently hiding in plain sight?
Exactly. Insights just waiting for the right hybrid model, the right combination of human knowledge and machine intelligence to reveal them and maybe fundamentally change how we build, use, and interact with AI in the future.
It's a fascinating frontier.
It really is. Yeah. Something to think about. Well, thank you for joining us on this deep dive today. Keep exploring, keep questioning these fascinating intersections, and we'll see you next time.